Do you love your Z-Box like I do, but wish it did more than just Z-Wave? Guess what? It actually does. Thanks to QuickApps and its Lua capabilities, it can be expanded quite a bit. This is Darren from Save the Panel, and let's take a look at some QuickApps I've written to bring the Shelly IP-based universe to the Z-Box. The need for this started with the Shelly EM devices, the ones with the CT clamps that I had in my panel, and I'd love to get that data into the Z-Box. I realized there was a rich RPC protocol available for all of these IP-based Shelly devices. So I figured, hey, if I'm going to write a quick app for one, I might as well write them for all of these devices you see, which make up everything I had on hand here on the test bench. So as we go through this, you'll see a number of quick apps, each related to a specific family of devices. And as I started to work on this project, I realized that the data that comes out of the devices is each slightly different based on the device type. Also, that required a different type of quick app in the Z-Box. So this meant I needed to have multiple quick apps. I'd love to just have one quick app where I could have it auto sense the device type and set everything up appropriately, but unfortunately that's just not possible because the quick app itself would need to have a default device type in the Z-Box. So as a result, we have multiple quick apps that had to be developed. So here's a list of the quick apps by device family, and I included the IP addresses here on our test bench because in a minute we're going to add one of these and I'll show you how the additions work. But firstly, the EM family, that was the older style Shelly energy monitors with the CT clamps, which are different than the EM Gen3s because of formatting differences in the code. We broke that out into a separate quick app. The Shelly PM Mini, which connects inline to the power going to your device, is separate. And then we have a relays/plugs device family, which includes anything that acts like a relay, including the Shelly plug, the PM Mini, the 1 Mini Gen 4, the 1 Gen 4, that's the one that's larger form factor that can do DC also. This should also work with the full-size Shelly 1 PM as well as a number of other relay devices as long as they follow that particular RPC protocol. And what's neat about this particular one is the plug has power monitoring and also a luminance, so this quick app will automatically create children for those two things, which you can turn those children off and on depending on what type of device it is. So it's nice and flexible. And then lastly, the Shelly i4 needed its own quick app because it is a remote control device. There's some really differences in the quick app for the i4. It works a little differently than the other quick apps in terms of how it polls, and maybe in future versions I'm going to spread some of that goodness to the other quick apps. We'll talk about that in a minute when we get into doing a little bit of a demo. Okay, so how in the world do we use these quick apps? Well, first of all, where do you get them? You can find them in a few places. If you start at our website at savethepanel.com, go to the discussion forum, and you can search for Shelly. Here it's one of our most recent posts, but this is all about the quick apps, and there is a link to our GitHub page. And here you'll find the repository for this particular set of quick apps. I tried my best to document the installation process and the various variables to set up, but just for right now, I'm going to zoom through setting up at least one or two devices just so you get the feel for how this works. Also, I've put this out here in two ways. One is in each of these you will find the actual Lua code which also I tried to standardize the documentation as best I could. So if you wanted to fork this or dig into the details, you certainly can. However, if you prefer an easier way to install, I do have these as releases as well. So if you go into the latest release, the actual FQA file is here, which can be simply imported into your Z-Box. So I will probably use the FQA method for this demo since it's the most straightforward. So let's do this. Let's load a Shelly plug directly, and actually here's a plug I already have. I'm going to go ahead and delete this so we can put it in again. Okay, so that device is removed, and now we're going to need to add a Shelly plug. So the first thing we would do is go to the GitHub, and the Shelly plug is actually supported here, and you can see the Shelly Gen3, Gen4 switch and plug on off controlled power monitoring is this relay-QA file. So we'll download that right here, and we have it. You can see I already had it, so there's a second instance out there, but that's fine. So we're going to add device. In this case, it'll be another device, and we're going to upload a file since we have the FQA file. And open the FQA file that we just downloaded. And it's imported successfully as device 512. Now, if you watch this, what's happening is the device loaded a Shelly relay, and it automatically creates two children, one for a power meter and one for a luminance. It's going to do this every time you install it, and then you'll be able to turn on or off those illuminance or power meter children depending on the capabilities of your device. So the first thing we need to do is configure this. So if we go into the Shelly relay that was just added, and under variables, here's where you'll see an awful lot. This is the IP address of the Shelly device itself. Now in this case, this plug is, I just need to find it here, is actually .225. Oh, look at that. I baked it into the FQA. Didn't even realize it. So that is the IP address of my plug here on the test bench. The OID is if it's a device with multiple switchable inputs, that would be the input ID 0 or 1 and so forth, so it stays 0. Poll interval, this is 10 seconds. So every 10 seconds it's going to pull the plug for status, so that way if you manually push the button on the plug, you'll know it 10 seconds later. It also will pull over illuminance and power every 10 seconds. This is configurable, and it's probably a weak point of the QuickApp right now, but you know, this is a beta version. And then I have some of my Shelly devices secured with a username and/or password. This gives you the ability to support that. So if you've not set a password, just leave it at these defaults. It'll default to using no security. If you have set a password, you would simply update this variable. And if you change the username, some devices do support that, you would edit this field here. Power report and lux report, this turns on and off those children. If you set that to anything other than, if you set that to false, then the power report child will disappear. And if later you want it back, you can set it to true and the child will come back. And then lastly, just for my own sanity, I have it pulling back the variables for power, energy, lux, illumination, etc. From the plug. And dropping them into these variables so you can see them. So now that we're at the correct 225, let's see if this is actually working. So I'm going to go up here and click this button, and we have nothing working. So that might be because of security. Let's go ahead and look at our console. This is QuickApp 512. We'll pull up 512. Oh, HTTP status 401. And there you go. So I went to the IP address of that plug, and sure enough, I do have security turned on. So let's find the password for that and add it. Okay, so we're going to add the password here. And, right now it does show the password in clear text in the Z-Box, other area for improvement, but we'll get there one day. But now that that's been added, we have to hit save here to save those variables. And then this should start coming to life. And you can see down here in the logs that it is bringing in values, which is good. So right now that light is off, but let's check out illuminance and go to preview. And we are seeing some lux levels. Now, by the way, this device pulls illuminance in only a couple of levels, named illuminations of twilight, day and night, things like that. So it's relaying that word of illuminance level as per the Shelly spec and doing a little math behind the scenes. Power meter, this should be 0 because nothing's on, but let's go ahead and turn it on. I should have a little bit of power draw. And this will take just a bit, 10 seconds to refresh here. Okay, we got to refresh, so we'll go, oh, it was there before I came out. So there you go, 12 watts. We just have a little bulb plugged into that plug. So yeah, so we're seeing power, we're seeing luminance, and we certainly have control. And if you were to build scenes with this, it will work. So if I add a very simple block scene, all of this this goodness is available. So let me just we pick that relay. We can base a trigger based on the relay state or on the power meter state or illuminance state. If the light intensity level is so many lux, then go do something. So very very usable, and certainly on the output side we can do the same. Turn the light off and on or toggle it just as you would expect. And I guess the last thing worth seeing, only because I have one of the live power meters set up here in my my house. Let me find it real quick. There we go. Now this one, so if you actually go to that IP address of that device, you can see that this is my HVAC is running downstairs. So this is the outside condensing unit currently running 1425 watts. And sure enough, if we were to open up the Shelly, at the high level, you see the combination of both A and B clamps, and you'll see 1421, and that's because the B clamp is at 0, but the A clamp is at 1418. So all of these QuickApps basically load the same way with very similar variables. There is one noted difference, which is the Shelly i4. What the Shelly i4 does differently is, because it is a remote controller and we are counting key presses or looking for key presses on the i4's switch input specifically, we can't wait for a polling interval of, say, 10 or 30 seconds, because it just wouldn't be very responsive. Why would anybody want that, right? So what this QuickApp does is it actually reaches out into the Shelly itself and puts some code into the Shelly i4 that says every time there is a switch action, to send that information to the Z-Box. So what the Shelly needs to know is a username and password on the Z-Box in order to send that information. So when you look at the variables for the i4, you'll see the usual suspects: IP address, the username, password of the Shelly itself, if there is one. You'll notice the default polling interval here is much longer at 30. You could make this whatever you want, because it's going to reach out directly through an RPC call when it needs to connect in. So here is where you put in your Z-Box username and password for your actual Z-Box. Don't worry, everyone, I've already changed this password by the time this video goes to print. But what I would recommend here is don't use your default username. Create one just for this purpose, and then limit that device, or excuse me, that user's security appropriately. And you can even limit what devices a given user in the Z-Box has access to. I'd recommend limiting that as well, just to be as secure as possible. What happens when someone does push a given input is it actually populates a string variable. So here you'll see this I4 has 4 inputs, 0 to 3, and that the variable is populated with what actually happened recently. So the last time this was tested or used, a triple push happened on input 0. If I right now, I just did a double push. So if I leave the variable screen and go back in, you'll now see that it says double push. Now what that means is that when you go to write scenes for this, you're actually going to not do that in the normal way, but what you're really going to do is check for changes in that variable. So here's what a scene might look like. The variable names, and by the way, all this is in the documentation, but the variable names are Shelly underscore I4 underscore the device name. In this case, it's 475 underscore event. And when that event equals, and then there's in the documentation single strings for the input and the type of push that happens. So that way you can have multiple Shelly I4s, your variables are not going to step on top of each other, things are going to work very well. You even have the ability to customize that variable name if you like on a per device basis. So this could be, you know, front entry scene controller, right? Or if you wanted it to be rather than I4 475 event in that case. And then based on that, you know, do an action, turn a light on, you know, set a light brightness, turn it off, you know, etc. Whatever you need that Shelly to control for you. So I also wanted to show you here on the i4 what is that script that is pushed in by the QuickApp to send those button presses on demand. You'll see the script here under scripts, you know, I'm not going to scroll the whole thing here, but it basically says whenever there's an action, make an HTTP call back to the Z-Box using the credentials that you gave it in the setup, and populate or update that variable in the Z-Box with the button press that was done. Also, what I did have to do here, because I am using a momentary button, is I did have to change the input type to button instead of switch for this to work properly. It could work with a switch as well. It wasn't tested that way, but it definitely should work. And if we need to refine that in a future version, or people want that, just leave a comment over on GitHub or lodge an issue, and we'll resolve that in a future version. So it may go without saying, but I'll say it anyway. These devices need to be configured in Wi-Fi mode, so they have an IP address. You should make that IP address a static address for this to work reliably. And this may work with the Pro devices as well that are hardwired Ethernet. I just had none on hand to actually test with. If you've made it this far, I really appreciate you watching and dedicating the time to this, and I hope to author some more QuickApps in the future. So please leave your comments below. If you should have any issues with these QuickApps, please open an issue on our GitHub page so we can get those fixed as soon as possible. If this video was helpful, please hit that like button. If you're not a subscriber, please hit that subscribe button so you don't miss what's coming next. Check the description below for product links, resources, and more details from the test bench. And if you'd like to support the channel and the Save the Panel community, sharing the video really helps. You can also use my Buy Me a Coffee link below if you're feeling extra generous. Until next time, I'll see you online.